A very good morning to all of you. I am Sharma, lecturer electronics at Government Polytechnic College Bikaner. Today in this video lecture, I am going to discuss about the Laplace transformation. Laplace transformation is a very powerful tool for analyzing the circuit with the sinusoidal or non-sinusoidal input. There are the various advantages to use the transformation as the Laplace transformation or Fourier transformation in circuit because this transformation convert the time domain signal into the frequency domain signal, and it is a very easier to analyze the circuit in the frequency domain rather than the time domain. And using the Laplace transformation, we have another several advantage. The Laplace transformation can be applied to the wider range of a signal than the Fourier transformation. And Laplace transformation also convert the complex differential equation into the simple algebraic equation, and solving the simple algebraic equation we get at the complete response of the signal. And the Laplace transformation in a single transformation give the complete response, natural plus forced response. So it's a very better approach to analyze the circuit using the Laplace transformation. Let's start the Laplace transformation. The definition of Laplace transformation or formula can be written as the Laplace transformation of signal f of t, also known as the capital F of s, is given by integration limit lower limit 0 negative upper limit infinity f of t e to the power minus st dt. Here lower limit is o negative. It include any discontinuity and abnormality at the origin, and s is a complex number given as sigma plus j omega. Sigma is a real quantity and omega is a imaginary, and the unit of s is the inverse of the second. It is known as the unilateral Laplace transformation. For the bilateral Laplace transformation, the lower limit is minus infinity and upper limit is plus infinity, and the remaining are the same. Normally we use the unilateral Laplace transformation in the electric circuit analysis. If the signal ft are the both sided signal, it's have some part in positive and some part in negative side, then we convert the ft into a single sided by multiplying ft to ut. You will see the in the later case. The inverse Laplace transformation or L inverse of f of s or f of t are given as integration sigma minus j infinity to sigma plus j infinity f of s e to the power st ds. It is a formula 2 pi j. Its formula is rarely used to convert the inverse Laplace transformation. Normally we use the lookup table or the Laplace transformation in formula direct to get the inverse Laplace transformation. Ft f of s direct to ft. Let's start some example to understand how we get the Laplace transformation of some common signal. We will use the very common signal like the ut, unit step signal, delta t, impulse, and e to the power minus at ut. It's exponential decay function. We all know that the ut is a unit step signal. It's known as the ut is 1 for t is greater than 0 and ut is 0 for t is less than 0. If we formulate ut is equal to 1 for t is greater than 0, ut is 0 for t is less than 0. Applying the Laplace transformation formula, Laplace transformation of u of t or 0 minus to infinity ut e to the power minus st dt. Here ut is 1 for this given limit 1 dot e to the power minus st dt. The integration of e to the power minus st is equal to minus 1 upon s e to the power minus st 0 to infinity, or we can simply say that minus 1 upon s 0 plus 1 upon s 1. So the Laplace transformation of the ut is 1 upon s. Secondly, we will take the Laplace transformation of delta t. Delta t is the impulse function whose value is only at the origin, and other than origin its value is 0. we apply the Laplace transformation of delta t. This is 0 to infinity delta t e power minus st dt. Here we can say that the in this limit its value it's only at origin, so e power minus 0, its value is 1. For the exponent decay function e power at ut, we apply in the formula Laplace transformation of, let's consider signal as a ft integration minus 0 to plus infinity e power minus at ut e power minus st dt. Ut will be 1, ut's value will be 1, so minus 0 to infinity e power minus at we will consider at 1 e power minus st dt. 0 minus 2 plus infinity, we will take the power common as plus a t dt. Simple integration will be apply minus 1 upon s plus a e power minus s plus a t. It's a plus, it's a t. Limit will be 0 to infinity. Minus 1 upon s plus a 0 plus 1 upon s plus a 1. S plus a. Thank you very much. In the next video lecture, we will go through the simple properties of the Laplace transformation, and then we will discuss about the inverse Laplace transformation and partial functions. Thank you very much.